Welcome. Cranium is Molecular Knowledge Systems' physical property estimation software package. Until recently, Cranium was only available as a desktop application. In 2023, we have begun offering a web server edition of Cranium. This web page demonstrates some of Cranium Web Server's key capabilities, including data retrieval, molecular structure display, and physical property estimation. To begin using this web page, select one of the chemicals listed in the Chemical Names table. If you cannot find your chemical of interest, it is very likely that Cranium is using a different name than the one you commonly use. In that case, you can enter the name you typically use, or even just part of the name, in the input control below the table and press the Find Matches button. Cranium will search through its database, finding those chemicals whose name or synonym contains your entered value. For example, here we typed NMP, which is a common synonym for N-methylpyrrolidone. Pressing the Find Matches button, Cranium returns one matching name, 1-methyl-2-pyrrolidinone, which is another name for N-methylpyrrolidone, or NMP. To display and generate estimates for NMP, we begin by clicking the left mouse button on the chemical's name. The selected chemical is copied to the selected Chemicals control. Press the Get Data button to display both synonyms and the chemical's molecular structure. Scrolling through the synonyms table, we see that NMP is listed as one of the chemical's synonyms. To view some of the constant properties of NMP, scroll down to the Constant Properties section and press the Get Values button. The web page will prepare a request for several constant physical properties and send that request to our online Cranium web server. Cranium will then retrieve physical property data for the named chemicals, dissect the chemical's molecular structure into groups, and use group contribution and equation-based techniques to estimate physical properties. The resulting property data and property estimates for N-methylpyrrolidone are shown in the table. We have data for molecular weight, melting point, boiling point, and critical properties, and estimates for many of the properties listed. Comparing the data values and estimated values shows that the estimation techniques in this case are giving fairly good results. If you click on the reference citation of any datum within the table, the web page will retrieve the bibliographic information for that reference from Cranium and display the information below in the Details control. Similarly, if you click on one of the techniques citations, the web page will retrieve the bibliographic information for the technique used to estimate that particular property and display the information again in the Details control below. To retrieve data and estimates for temperature-dependent properties, scroll to the Temperature-Dependent Property section. Use the Property control to select the property you're interested in. Select the units in which you want data and estimates to be displayed. Pressing the Get Data button again sends a request to Cranium. Cranium searches its knowledge base for available data and, if found, returns it back to the web page for display. To generate temperature-dependent estimates, begin by entering the minimum temperature, a maximum temperature, and the units of these temperature limits. Then press the Get Estimates button. The web page will package these input values into a request and then send the request to Cranium. Cranium will process the request, generating estimates for a series of temperatures between the entered limits, and again send the response back to the web page for display. In addition to the tabular display of data and estimates, the temperature-dependent properties section also provides a graphical display of these values. In the graph, data are represented by blue squares, and estimates are represented by green diamonds. For NMP's surface tension, the agreement between data and estimates is quite good. To display or estimate properties that are dependent on both temperature and pressure, scroll down to the Temperature and Pressure Dependent Properties section. Again, you can select a physical property and that physical property's units. To retrieve data, press the Get Data button. In this case, the web page notifies us that there is no data available in the current knowledge base. So we will need to estimate values of the liquid density as a function of temperature and pressure. The web page only varies one state variable at a time. In this case, we will fix the temperature and vary pressure. Select temperature from the state variables selection table and enter a fixed value of 273.15 in units of K. We then enter a pressure series starting at a minimum of 0.1 megapascals and going to a maximum of 40 megapascals. Once we have entered these state variables, we press the Get Estimates button. Once again, the web page will compile these input values into a request, send that request to Cranium, and display the resulting values. The table to the right shows these estimated values, and the graph below shows these density estimates plotted as a function of pressure. We hope you find the MKS Physical Properties webpage useful. Please contact us if you have any comments regarding this webpage's functionality, have suggestions for additional chemicals, data, or estimation techniques, or have any questions about physical properties in general. Thank you.